Okay, hello again, FS122 mid-year. So I hope you enjoyed your very short, long weekend in terms of taking a break from your academic duties. Although I do think that some of you will probably use the time to catch up with your other modules, and that's entirely up to you. So we'll be discussing optical properties, which is still technically an offshoot of electromagnetic waves discussion. No? Since optical properties are based on visible light, which is an electromagnetic wave. So in general, we'll be discussing the response of food materials to absorption of electromagnetic radiation in the visible spectrum, and we'll include on top of that yung infrared and near-infrared and ultraviolet light as well. So this includes colorimetry and discussing transmission, reflection, and refraction. And then we'll also be having a bit of a discussion on the use of near-infrared um, technologies, spectroscopy techniques for elucidating molecules. Alright, so most of you indicated in your self-introductions na ang natatandaan ninyo sa physics, among other things, ay yung mga experiments ninyo on optics as well as yung mga gumagawa kayo ng bridges, catapults, and dropping eggs from a certain height. Well, I don't know how many of you were able to do those experiments, but I think more than a handful naman. So anyway, optics was probably memorable because you had to say pass light and see it sort of bend. And we know, of course, that that bending of light at the intersection or interface of two different materials where it passes through is called refraction. No? Na yung apparent change dun sa excuse me, speed of the travel of light causing it to appear to bend. So here are some concepts that we can recall. So again, when light hits an object, say this is air and this one is, say, glass. Some light is reflected and we have the angle of reflection, alpha. Okay, and some light is also refracted and we have the angle of refraction, beta. And in this case naman, so if we have light hitting a material, different material, so you can measure the angle alpha and beta, and the ratio of their sign would be equal to the ratio of the speed at which nagta-travel yung light at material 1 over material 2, and consequently that is equal to the inverse of yung ratio ng refractive index n mo, n2 over n1 equal to sine alpha over sine beta. So CO is just the speed of light in vacuum. So this relationship of the sines of the angles to the ratio of refractive indices is often referred to as Snell's law. However, its validity is limited for use in what we call regular geometric optics, where there are small wavelengths and the media is optically transparent. So obvious na makikita mo na medyo may pagka see-through yung media like air or glass. So one way to measure the refraction index is to calculate it from measuring the angle of incidence at which the angle of refraction equals the angle of total reflection, or 90 degrees. So as we know, di ba, if for example, this is the interface, dito manggagaling yung light natin, depending on what angle your light beam is approaching, magbabago yung angle of refraction na makuha mo. But at a certain angle of approach, with respect to the surface, the interface, the angle of refraction will be equal to the angle of total reflection, which is 90 degrees. or parang doon sa direction ng surface mismo, like this in number 7. So in which case the beta would be 90 degrees. So we simply try to find the angle alpha at which the beta will be equal to 90 degrees. And since that sine 90 is equal to 1, then you could calculate then for N2, or the angle of refraction of the material 2 mo. Okay. Alright, so in real life, we have these refractometers which measure the refractive index of materials, no, usually liquids. So we may have used the handheld or benchtop refractometers, whether electronic or yung manual, yung parang sinisilip mo na parang telescope, okay, in your other FS subjects. There are also inline flow cell refractometers which measure your refractive or refraction index in real time as the liquid passes through a product pipeline in a production setting. Okay. For reference, of course, here are the refraction indices at a specific temperature, because as we know, it's affected by changes in temperature, no? May temperature correction factors tayo for some aqueous materials, okay? And even glass and diamond. So most of the refractometers we use for liquid foods or food processing components like brine, gumagamit po sila ng hindi refraction index mismo yung dinidisplay nila, kundi usually what we call degrees Brix or Brix percent, which is related to the percent soluble solids, no? So technically it's calibrated to more or less display yung amount of sugar dissolved in a aqueous solution. Kasi when you add more sugar to an aqueous solution, nag-change yung refraction index ng solution na yun. And yun yung basis for this one. Although it's calibrated such that more or less you can say na yung percent sugar niya ay nakakorelate sa kung anong degrees Brix yung mabasa mo. Okay? And here are some sample Brix values for different food and non-food materials. More often than not, this reflects the amount of sugar. However, it does read any soluble solid. So kung merong acids or maybe salt, nag-reflect din dito. Pero kung purely sugar and water lang yung solution mo, typically, when you say 20 Brix yung reading mo, then that more or less means na around 20% sugar yung solution. Okay, pero syempre, pag nilagay mo ng asin and acids yun, then hindi na equal lang sa sugar yung nababasa ng Brix. Although each component you add can vary the refraction index differently. So adding 1 gram of sugar versus 1 gram of salt will not make the Brix rise by the same value. Kasi syempre iba yung effect nila sa change ng optical properties ng water in this case. So as you can see here, those products containing very high sugars are typically mataas din ng Brix. Now, I remember in particular when we used to make sa, ayan, naka-Magnolia shirt na naman ako ngayon, sa Magnolia ice cream plant. Para makatipid kami ay kwento muna na gumagawa kami ng yung syrups in-house. So kung mapansin nyo minsan yung ice cream na Magnolia like yung chocolate or strawberry, may parang strawberry syrup or chocolate syrup na kasama, nakaswirl dun sa ice cream. So ripples ang tawag namin dun. And to save up on money, our boss said, let's do this in-house. Imbis na bumili tayo sa supplier, gagawa tayo ng equipment na para magawa sa in-house. So it's a steam jacketed kettle with a circulating pump, and it's basically making a flavored sugar syrup, no? And one of our tests for doneness is using the refractometer to check yung proper dissolution ng sugar, no? Kasi kung hindi, as we know, ang syrups mataas ang sugar content, like nasa 60 plus bricks yan. Okay. And then, syempre, kung hindi pa dissolved yung sugar mo, hindi siya mababasa dun sa refractometer, right? Like even if you have 60% sugar, 40% water, you put it in a container, if hindi na dissolve yun, hindi mataas yung magiging bricks reading niya. So that's one of the things that we check, quality parameters, to check the doneness of the syrup's cooking, no? Kung gaano ka-dissolve na yung sugar doon, and as well as check the temperature, because as we know, yung para ma-dissolve siya ay tumataas yung boiling point ng syrup mo because of colligative properties. And by the time it boils, it's not boiling at 100 degrees Celsius na lang, somewhat higher. I think you did those experiments from FN 102. So, yun, that's konting backstory lang. Okay, here are more examples of refractometer. So here's a benchtop, a portable type, and a inline types. Okay, so typically, yung mga mas mamahalin, of course, yung mga smaller refractometers, they usually display in degrees bricks lang, no? So if you haven't used something like this, you put the liquid sample over here, papatakan mo, and then magsha-shine siya ng light from underneath. Tapos it will have its way of measuring the refraction index, and then will give you a bricks value. Okay, of course, some of the more high-tech equipment can tell you the actual refraction index rather than just giving a bricks value, no? So, and then of course, over a wider range, kung matitignan nyo yung ibang refractometers, like in the previous slide, may limit kung hanggang ilang degrees bricks lang yung kaya niyang i-display. So, and usually some refractometers, even the electronic ones, hanggang minsan 80 plus or 90 plus bricks reading. But again, some of the benchtop ones can actually display refraction indices instead of bricks values. Alright, so when you have the foods, no, na medyo one-sided yung nilalagay mo na solid, like let's say brine na salt and water lang yung laman, syrups na sugar and water lang yung laman, or alcoholic substances na walang halong ibang solids. So there are, of course, refractometers specific for this, no, like a specific salt content refractometer and a sugar content refractometer. Of course, when you're doing that, you have to take note that adding other soluble ingredients can interfere with the reading in terms of kung salt refractometer yan, nilagyan mo ng asukal, obviously, hindi na tama yung magiging reading nun. Okay? So, sometimes you just use total soluble solids. Useful din ito, we use this also in ice cream mixes, for example, to gauge whether or not kompleto na yung nailagay na ingredients. No? Hindi ko alam kung nakwento ko na nga before, but there was one time wherein as a QA, I took routine readings of the total soluble solids of the ice cream mix and found out nga na masyado siyang mababa, and therefore something is obviously wrong with the formulation. And upon checking with the production crew, they realized na may hindi sila nalagay na isang sako ng asukal, which corresponded to the around 3 to 5 bricks lower than normal reading. By the way, when you're using yung mga refractometers for total soluble solids, usually fats and oils may interfere with the reading. So kung nakita nyo dun sa few slides before yung bricks tapos yung may blue line separating the white sa ilalim. So minsan lumalabo yun, no? And even if you were to use a digital refractometer, the refractometer, which usually gives a single value upon repeated measurements, will give you multiple values upon multiple measurements. So anong example nito? Nung ako po yung nag-OJT sa Liqueur de France commissary under the Pancake House Group, pinapakuha sa amin yung refractive index nung mga mayonnaises na ginagawa nila doon. Okay, yung pang parang sandwich spread nila, kani sandwich spread. Sarap siya in fairness. Okay, so and usually ang problem namin doon is we had a digital refractometer. If you press the refractometer 5 times, it will give 5 different readings. And minsan pinapapili ka na lang kung anong reading yung i-report mo. Okay, syempre dahil OJT ako, susunod lang ako sa kanila. In hindsight, mali na gamitin mo yung refractive index sa high amounts of fat and oil like mayonnaise na emulsion kasi talagang hindi mo makuha yung tamang reading. It's the wrong instrument for the wrong purpose, and I can't see why they needed to measure the soluble solids of mayonnaise. Baka may ibang measure na dapat mas tignan, no, kung gano'n na lamang. Alright, and also using different instruments, you can also measure the refraction index in fats and oils. So definitely you shouldn't be using a bricks refractometer for that. Alright, so I said earlier that there's a different refractometer for salt and sugar, no? So, and that there's a relationship between the refractive index of a solution and the bricks display. So essentially, when you have a, let's say you have a yung sinisilip na refractometer which displays from 0 to 30 bricks, okay? So what that simply measures is the refractive index, but it gives you the convenient bricks in value instead because the definition of 1 bricks is the refractive index ng 1 gram sugar per 100 grams solution. Okay, so if you have a 26 degrees bricks, then that means you have a solution of 26 grams sugar and 74 grams water. All right. Take note that when you're using salt, so for 1 gram of salt, it has the equivalent refractive index altering properties of 1.3 grams of sucrose. And that is why when you have a solution containing both salt and sugar, for example, you can use degrees bricks to assess the relative amount of total soluble solids, but you cannot say how much of that is salt and how much of that is sugar. And of course, you cannot say that there is a total of 6 grams soluble solids. Halimbawa, kasi hindi naman 1:1 yung bricks to salt gram ratio, no, pagdating sa refractometry. Kaya nga there's a different salt refractometer, aptly called a salinometer, for this purpose. Kung salt in water solutions lang yung ginagawa mo, such as brines na pagbababaran mo ng mga isosalting mo ng mga maybe isda or whatever. Okay, at this point, I am not sure if you have discussed colorimetry in any other subject, but it's simply trying to quantify colors or visible light using a certain color space. So definitely, if you've been using computers, you're probably familiar with RGB or sRGB. Lalo na yung mga graphic artists, no? Yung mga kinakalibrate pa yung mga computer screens nila para make sure na mas accurate yung color rendition, especially when translated into print. But definitely, in food, mas ginagamit din natin ito since, for example, for quality control, we want to quantify the limits of the variability in color. As I may have mentioned before, Magnolia Stories ko na naman, there is a very subtle difference between the white color of, let's say, a buko salad ice cream base mix and the slightly off-white color of vanilla. And again, although we do not have a colorimeter in the lab, visually we are able to assess this through training, no? Para masabi mong, uy, hindi nyo pa nalagay yung kulay ng vanilla flavor. That's an off parameter sa quality. So please stop the production because we don't want to sell vanilla that is not of the right color. Anyway, again, so yun, the visible light spectrum again is between 380 to 750 nanometers. Apologies dahil naka all caps yung font na ito kaya laging large yung nanometers. Alright, so in colors mixing, lalo na sa inyo siguro yung mga artsy nagpipaint or what. So there are two ways to manipulate colors now. One is through mixing different wavelengths of light to produce another color, and this is called additive mixing. And one is through the elimination of certain wavelengths of light through filtering, which is called subtractive mixing. So maybe you've encountered this if you ran white light through a sort of colored filter and it becomes colored light because it subtracts the other colors of light from white, no? And you may remember your Beer-Lambert's law from your chemistry, maybe dun sa UV-Vis spectrophotometry exercise ninyo. Okay. So again, when we deal about color, you've probably known by now, no, that the color that we see is based on the color that is not absorbed or what is reflected. So for example, in red wine, the anthocyanins absorb the green wavelengths, and because of this, it is the non-green parts equivalent to the red parts which register in our eyes as colors. Okay, and when the other types of wines absorb yellow light, it leads to a perception of a blue reddish color. So again, sa Beer-Lambert's law, this may sound familiar but of course, iba yung gamit na terms na ng ating book, no? But this is essentially yung absorbance, di ba? And then yung coefficient, the molar concentration, and the path length or thickness. So it's essentially the same thing that you'd remember from your chemistry or spectro lessons in food chem. Alright, so when it comes to color perception, there are many factors that could come into play. Okay, one example is when you have a green glass na wine bottle, but when you crush it, it now becomes white. And that happens because when you reduce the particle size, okay, geometric property of glass, you increase the surface area which reflects more light. So light is more actually a perception thing din, ano? And that's why the observer in this case is also a factor. Na kung saan ka nakatayo ay nagdedepende doon kung ano yung nakikita mo or yung napaperceive mo na kulay. And well, this can't be more truer for LED TVs. Anyway, these factors include the type of illumination, syempre yung kulay ng ilaw mo, whether it's white light or another color, and the angle at which it hits the object. Okay, the transmission of light through a certain material. Okay, and then the properties of the surface of the object being hit with light. So, nandyan yung absorption, emission, or reflection. So, all of these things affect how we perceive the color. And it is therefore important that we control as much of these as possible. So, for example, if you're assessing the color of yung vanilla ice cream, you have to make sure na hindi yan observer error lang kaya na feel mo na mali yung kulay niya. Kaya nga sa food sensory evaluation, we have a standardized procedure, yung 45-degree angle when you're looking at your object to assess for its color, di ba? So, konting throwback lang to our FS131 lectures, either Sir Jean Mark or I. So, syempre dahil ang ginagaya natin sa colorimetry ay kung paano nakikita ng mga mata yung kulay, then we have to more or less understand how our eyes work. Again, we have both rods and cones in our eyes, rods which are sensitive to brightness or darkness, and cones that are sensitive to red, blue, and green colors with their specific absorption maxima um, wavelengths as stated here. Okay, here we have what we call the color triangle, the chromaticity diagram. So as you can see, clockwise from this point is increasing wavelength siya. Okay, and then as you can see, may point E dun sa gitna which denotes the white color. And outwards, radiating outwards from point E is what we call yung brilliance. Okay, so which is parang from pale to brilliant, and when it becomes too pale, it would appear white. Okay, and then if you wish to do additive color mixing, you can take any, you can just draw a line between any 2 points, and yung line na yun would indicate ano yung kalalabasan ng mix. So for example, if I were to mix green and blue, pwede ako makakuha ng greenish blue, blue-green, etc. Or if I were to mix purple, blue and red, I would get the purple hues and so on. Okay? And if there's a line passing through E, then that means mixing those two colors in the right amounts additively will result in a white color. Okay, so take note that this represents colors in an XY axis, and therefore among the many color spaces, this one would have colors represented as XY coordinate values. Alright, so as a vector quantity, we can quantify color in a number of ways, and one is using the hue and hue chroma brightness na system, no? So hue is a general region within the chromaticity diagram. Okay, the chroma determines the color or colorlessness. So the concept is a bit similar to saturation if you've tried maybe editing images on your phone, di ba? And the brightness is the degree between darkness and maximum brightness. So, of course, madali naman tong intindihin dahil yung mga phone natin may brightness adjustment, and of course, if you've tried editing pictures as well, you can see the effect of increasing brightness for a specific color. Okay? So it becomes either too dark that you don't see anything, or too washed out that it becomes pretty much all white. Alright, the human eye can distinguish around 200 hues, maybe naming those 200 colors, up to 25 degrees of chroma. Maybe, ano to, no? Pwede nating i-prove to using sensory tests, mga triangle and ranking tests probably, and 500 degrees of brighter. Okay, so when you combine all of these, then you have millions of colors that you can possibly make. And that is why if you, let's say, have been following video game history, one of the fights into making video games better was producing more colors. No? You start with 8-bit, which had 256 colors. And then if you grew up and had increasingly better monitor screens, then you might have noticed the change in the maximum amount of colors, no? Depending on the bits, may 32,000 colors, 60 million colors, and so on. So one other three-dimensional color space is a CIE's LCH color space. You can pronounce this French acronym at your own risk. Okay, let's just call it CIE. And the LCH color space stands for lightness, chroma, and hue. So again, it's a color as a vector quantity in a three-dimensional space, wherein, as you can see here, the space would more or less represent a cylinder, a point in the cylinder, wherein itong axis na to, you have the blackness and the lightness axis, okay, representing your L. Then your hue of your color is represented by an angle from 0 to 360, and the chroma would represent its position along the maybe the radius of the circle. Okay, so you have a three-dimensional space that more or less forms a cylinder. Another type of color space is the LAB color space. Now, if you've used the Hunter LAB colorimeter in the lab, so that's an example of an LAB color space system. And although apart from yung Judd Hunter system or yung Hunter lab na tinatawag natin, meron ding LAB color system yung CIE. So there are some slight differences daw that they're not apples to apples when compared, no? Such that the same LAB values using the Hunter lab may render a slightly different color from the CIE lab. However, they do use the same format for the color space. So yun yung focus natin. Alright? So dun sa Judd Hunter, meron tayong brightness 0 to 100. And then the A stands for the redness to greenness. So 0 to 100 is red, minus 100 to 0 is green. For the CIE lab, bale ano yun, 128. So parang magkaiba lang yung ano nila, number of gradations. And sa B naman is yellowness to blueness. So 0 to 100 is blue. Is yellow, and minus 100 to 0 is blue. Okay, so again, sa CIE lab, 128 to 0, 0 to 128 and negative 128 to 0 siya. So probably it has to do with yung digital system niya of increments, no? So siya ay 8-bit in that sense, 256 gradations per axis. Alright, anyway, to remember this, no, gumawa ko ng medyo pilit na acronym, GARBY. So, para maalala nyo that green is negative A, R is positive A, B is red is positive A, blue is negative B, and Y is positive B. Okay, so GARBY. Yeah. So there's also the Munsell color system, which is similar to the hue, chroma, and brightness, both in terms of how they appear and the fact that they have a cylindrical space wherein you have an angle that's being measured, a distance from the center, and brightness on the z-axis. Okay. However, in this one, yung angle mo is alpha na nag-represent sa hue, ay convertible siya into your Hunter system using the following equations. No? Yung tangent ng alpha and yung distance from 0 can both be related to your A and B on the Hunter LAB color system. Munsell is also famous for having the Munsell Book of Colors. In the next slide, papakita ko yun. So it's simply color tile, parang catalog, no, for different colors within their color space. You can use it for direct comparison if you don't have a piece of equipment. Parang visual lang siya na comparison. However, that book is heavily calibrated and needs to be replaced in a regular basis kasi nag-feed yun or what. And that book of color costs a few thousand, hindi lang few, parang almost $1,000 ata. Depende kung gaano karaming color swatches yung gusto mo dun sa book na yun. No? Because of course, there's a library that's more, it has more colors than others. So here's the characterization of colors using the Judd Hunter system. If 0 yung L mo, 000, you'd have a black color. 5000 is a gray color. 10000 is a white color. And then if B is 0, any negative A value would result in a green tint. Positive A value would be reddish tint, blue tint for negative B when A is 0, and yellow tints for when positive yung B. So I can try this link. It's a color converter, although it uses not the Judd Hunter system but the CIE lab and also some other color spaces like RGB, etc. You can just play with it and try inputting values, and it gives you the sample ng color niya na tawag dito. Ipapakita niya sa yung color tile na. So I'll put up a slide sa susunod na may samples ng inputs and the resulting color for a CIE lab color system. So here's an example of varying the lightness from 0 to 50 to 100 with keeping a fixed A and B value. So a positive A value is red and positive B value is yellow. So ang lalabas sa kanya is supposed to be red plus yellow, and that's what you get. You somehow maroon to a was this cherry red and some sort of fleshy color. Okay, still playing with the NIC sensor converting using the CIE lab color system. So this time yung kaninang 50, 100, 100, ang ginawa ko naman ngayon is to vary the A value in 25 increments of 25. Excuse me. So L is 50, B is 100, and then yung A, which is greenness and redness, ay vinary natin. So it's 100, 75, 50, 25, 0, minus 25, minus 50, minus 75, minus 100. So as you can see, nag-change siya from red to orangey to somewhat brown, greenish brown, parang lumot-ish, okay, and then to green. So of course, it's also possible to use our sense of sight to evaluate colors, and that's why we have color swatches for when we don't have instruments that give numerical measurements. So as I mentioned before, there are sets of color standards such as the Munsell Book of Color. We have one sa Che, pero sobrang luma na niya na kailangan ng palitan. Okay, it uses a slightly different naming system for the colors, but you won't be discussing that na. You can look it up if you want. And we also have yung color swatches ng Pantone. Although if I'm not mistaken, yung Pantone, mas madalas siyang gamitin sa applications ng pintura. Tapos yung mga names dyan may yung colors merong adjective names, no? Like baby bottom pink, as in puwet ng baby, mga ganon. Alright, we also have one of these, pero luma na sa so medyo faded na siguro yun. Right, so of course we know again that sensory evaluation, the most you can do is tawag dito, analyze color under standard conditions of lighting and viewing angles. Okay, and as you can see dun sa previous slide, so we can do a somewhat triangle test or difference test for colors, no? Kasi minsan sobrang kahit anong squint mo ng mata mo, hindi mo na makita kung magkaiba ba yung kulay na yun o hindi, when in fact there's a minor difference. And yeah, other than Munsell and Pantone, we could also use fluid color standards made from aqueous solutions of chemicals which have, of course, a definitive color. So definitely a certain molar concentration of certain substances, metallic salts, would have a fixed color, no? In theory. Kasi chemically pure naman sila. And pati yung tubig mo naman, wala namang magiging variation sa kulay nun. So for measurement of color using instrumental means, we have two major equipment, the spectrometric equipment or the spectrophotometers, and the colorimeters, which rely on tri-stimulus measurement processes. No? So you are familiar by now with spectrophotometers and have done so, have used it, I think, both in your chem and food chem. So you know, of course, how long it takes for these actual spectrophotometers to generate information, because they scan the whole spectrum of colors. And again, that these are based on yung absorbance and reflectance, transmittance ng mga wavelengths of light doon sa iyong sample to give you data on color. So the good thing with this is it gives you a lot of information, though at the same time, malaki yung equipment mo, medyo mas matagal siya, and chances are mas mahal yung equipment. No? Some spectrophotometers are more expensive than brand new cars, or at least as expensive as one. Tri-stimulus techniques, on the other hand, use color filters that simulate colors in the human retina. Okay, although this doesn't mean RGB lang yung tawag dito yung kaya nilang i-generate na data, because of course we just found out earlier na pwede mo naman palang i-convert from one color space to another yung kulay mo. No? So actually yung Hunter LAB system natin sa lab uses the tri-stimulus technique. So what happens here, of course, you have a light source that illuminates the specimen. Specimen reflects light that is then detected by your RGB photodetectors, thus displaying a color based on your RGB. Okay. So here's an example of a portable colorimeter, in this case used to measure yung kulay ng cellphone. So in your lab video, merong portable colorimeter din doon. Mura lang yan. No? Less than 5K ata. So sa Shopee mo hinanap. Alright. So anyway, so that's what happens, no, in tri-stimulus. If you're familiar with how digital cameras work, we usually have sensors, which are either CMOS charged manganese oxide or CCD charged coupled devices. And CCDs usually have a pattern array of sensors na each parang pixel-like element could only detect one color. Okay, so and then parang nag-interpolate na lang siya using its processors to translate it into an image. Okay. So this is similar to our lab equipment in the pilot food plant. No? Nakatayo lang siya kasi may parang specific attachment for color measurement of specific things. So as you can see, sometimes there are product specific color measurements. So for example, the brewing industry uses the EBC color scale. No? So yung mga beer and whatever alcoholic beverages nila, so they have a scale, may number and may gradient silang ginagamit. Of course, you could also use maturity indices. No? You can either manually each time pick the um, process the samples para isalpak sa colorimeter, which maybe takes time. Or sometimes you can just make one of your own, gumawa ka ng true color swatches na applicable sa quality control mo. So as you can see here, makita naman natin talaga how maturity indices change the color. And although these could be quantified using whatever color system you might want to use, sometimes mas madali na bigyan mo na lang yung QA ng printed color cards na pwede niyang i-match kung saan bin mo i-classify yung maturity ng isang fruit, no? So, there, and as you know, you can use it for pretty much any agricultural commodity that changes color as a function of time, temperature, or whatever variable you may have. Okay, so sky's the limit, no, when you're thinking of applications for colorimetry. Basta kung creative kayo, may kulay yung isang produkto, may pinagdadaanan siyang color changes in the process or whatever step in the process, maybe during storage, during production, during processing, then you can use any sort of color measuring method, right? So one example of this is ito, quality control of batch by batch production. So inspection of pizza topping percentage distribution using computer vision. No? So you can do that by image analysis. Okay, you can also have automatic sorting or imaging. So in this case, real-time detection of corn kernels, yung defects in corn kernels, tapos automatically isa-sort. Then color as indicator in biological stress, such as in dehydrated or low nitrogen corn. And of course, there are many ways in which you can use color changes as a measurement of changes in food processing. So one example of its use is in dehydration, because we know that dehydration removes moisture and affects the color, because normally dehydrated products have a darker color, and there's extent to which these may reduce the acceptability of its appearance. And also you can use machine vision to assess quality, such as in using visual quality attributes of shrimp in assessing visual quality. So typically these machine vision use AI as well, no? Kasi may picture dyan, wala namang kakayahan yung computer unless turuan mo siya na pag ganito yung picture, ganito yung itsura, ganitong defect yan. So ito yung response na gagawin mo. Okay? So there. So technically, ang infrared is beyond the visible spectrum na. Kapitbahay siya ng visible spectrum dun sa red side, no? So technically, ito sana ay under ng electromagnetic. Pero sige, andito na tayo. So for NIR, we typically use 0.8 to 1,000 micron wavelength. However, because of tradition, pag NIR, ang ginagamit natin sa mga usapan ay yung reciprocal of wavelength, which we call the wave number. Okay? Parang yun lang yung common nomenclature. Alright? Much in the same way that traditionally because of influence, for example, di ba, ang mga Pinoy, ang weight ay in pounds if you're from the older generations. Anyway, um, so because just like any other spectroscopy method, ito po ay nagdi-deal with data on the absorption and transmission of electromagnetic radiation of a certain wavelength dun sa sample mo. However, yung information natin will only be useful if the molecules in question are capable of absorbing infrared radiation. The plus side is if they are capable of absorbing infrared radiation, then to an extent we can identify that type of molecular bonds in that sample. So with NIR, as you bombard your sample with NIR electromagnetic waves, molecules that are capable of absorbing electromagnetic radiation will react in a certain way. So yung bonds mo, hindi naman talaga yan rigid things, no? Na parang pag dinikit mo, hihila mong ganon. Think of them as maybe parang ropes or stretchy rubber stuff so that the bonds can be moved, no? So you can have stretching, pwede silang medyo para may pagka-elastic, or may scissoring na nagaganap, okay? So if you were to take a molecular level microscope and observe the molecules while they are absorbing near infrared radiation, then gagalaw sila, no? May parang vibrations, and these would cause the bonds to move in a certain way. So as you can see here, for the water molecule, different types of stretching or scissoring can occur at different wave numbers of absorption. Okay? So meron din naman tayong mga nomenclature dito. So if, for example, we are dealing with a certain frequency relevant to your sample, let's say, then I could identify that frequency as the fundamental oscillation. And if you double that frequency, it's called 1 overtone. And if you triple that, it's 2 overtones. So I'm not sure if to what extent ginagamit din ito yata sa mga music terminologies, no? Since we're dealing with frequencies, although not sound, but rather electromagnetic waves. And of course, if you double the frequency, you have the wavelength, and if you triple the frequency, the wavelength is 1/3. So again, what happens here now is if we scan the NIR spectra and emit it, the device would measure yung mga absorption niya at specific wavelengths, and using somewhat sort of a database based on kung saang wave number siya nag-absorb, malalaman natin kung anong bonds yung meron, and therefore kung anong klaseng molecule probably yung nandoon. Okay. So again, this gives us insight into the molecular structure, composition, and type of bonds. Okay, so here we can see yung absorption bands niya. Okay, so this is the fundamental frequency range, first overtone and second overtone. And we can see nakaparallel dito yung sa absorbance readings niya. And here we can see which bonds correspond to those frequencies or readings, no? Yung mga peaks nila. And dito naman we can see for different proximate components kung ano yung relevant na wavelength for them. So you have for water, which is OH stretch and a combination, Proteins generally have nitrogen H bond deformation. Fats usually have stretches in CH, and carbohydrates, yung mga CO and OH stretch and combinations at the specific wavelengths. Right, so one downside to this is, as you can see dun sa figure kanina, there may be some overlaps, no, na some bonds may appear over different wavelengths. Okay, so mahirap siyang i-interpret. But thankfully, that's one area wherein AI is good at, and they use algorithms to simultaneously analyze the components and give you an approximation of the results. However, you would have to calibrate for specific properties such as particle size, shape, and bulk density for the effects to be controlled. No? So, hindi ito isang magic pill na, oh, sige, salpak mo yan sa NIR tapos malalaman na natin yung proximate composition. Pwede, pero may caveat yon na kailangan may calibration siya. And of course, just like anything that's calibrated, you can end up with wrong results. So in terms of operation, the NIR spectrophotometer is similar to other spectrometers, no? So you have something that generates a beam and a monochromator that selects a specific wavelength. There's a sample holder or cuvette, and of course there's a detection system, either for reflectance or transmittance. So there are different types of spectrometers based on their mechanisms. So those are the filter type with movable infrared filters. There's a turnable filter, so which has optic filters which can be tuned, and those that use infrared light emitting diodes, those that use a grid or prism to select your wavelength, and yung kung narinig yung FTIR, Fourier transform na NIR spectrometer. So it has a built-in interferometer. Okay. So in terms of how the light from the source reaches the detector, there are different modes as well for NIR. Siguro sa mga familiar tayo is yung sample transmission na tagusan lang. You have the light source passing through the sample directly to a detector or sensor. On the other hand, it's possible to also have a configuration ng reflection. So obviously, you measure reflectance instead of transmittance in that case. So nag-reflect dun sa sample yung light towards a detector or sensor. And meron din tayong tinatawag na transflection, wherein behind the sample holder is a reflector. So it reflects the transmitted light to the detector. So if you've used spectrophotometers in your chem or food chem, you might as well be aware of its uses and advantage. No? So one advantage, of course, is that especially for liquid samples, no sample preparation is needed unless you're diluting it to a certain concentration. And then, although it's not instantaneously rapid, so to speak, the results would take minutes at most rather than, let's say, hours or days for other chemical methods. No? And in terms of calibration, we often use standardized samples with known composition, and then we run that sample or that standard through the spectrometer, and we test the computer algorithms kung magmamatch ba yung ibibigay niyang chemical composition doon sa actual composition ng standard sample. Okay. And then for wavelength, various physical objects can be used for calibration. So among the many applications, I've chosen a few to represent what you can do with NIR spectroscopy. One is moisture determination, na a rapid method. So this is not to be confused with infrared heating that evaporates water and determines moisture content gravimetrically. No? So this is of course using the near infrared to oscillate your water molecules and more or less determine how much water is in the sample. You can also use this to measure, let's say, the deterioration of fat during frying by looking at the changes in the amounts or the production of um, fat deterioration by products as frying time goes on. Maybe we can also use it to classify citrus oils. Of course, all of these assume na meron tayong enough of a database to for the computer algorithm to name the molecules based on the information generated from the NIR. Okay. Ito isa, we'll look at this some more in the next few slides, determining proximate composition in a near instantaneous manner versus the standard methods that we usually use in the lab that may take hours or days. We can use it for screening genetically modified organisms. Based na rin sa molecular structure pa rin ng difference ng GMO products perhaps than sa non-GMO. And then, of course, since bacteria are also things that have molecules in them, you can also differentiate bacteria by profiling them, yung kung ano man yung mga parts ng katawan nila na nagre-respond sa NIR. Alright, here's an instrument from Buki. If you remember sa Food Chem Lab, may mga Buki tubes tayo, no? So anyway, from that company comes the NIR proximate analysis instrument, no? So it's just this benchtop machine with a sample loading bay that can be used for a variety of different foods for near instant, hindi naman near instantaneous, very rapid proximate analysis in a non-destructive way. Okay, so marami siyang pre-calibration such that if it has something similar to your products on the database, then you can use those pre-calibrated settings para yun yung gagamitin niya pang determine ng proximate composition ng sample na i-feed mo. Alright, so here are samples of kung saan siya pwede gamitin, at least that specific instrument that you saw earlier. They have presets for commercial products like yogurt, cheese, butter, milk, and meats. So you can measure other than your typical proximate content of moisture, protein, fat, etc. You can also look at other parameters like lactose for dairy products and connective tissue for meat products. And obviously, since this is much faster than a typical proximate composition, pwede mo siya gamitin to make decisions on the fly, no? Like as production is going on, you can monitor the parameters of your product and pwede ka pang mag-adjust kasi medyo mabilis yung results niya. Like, uy, kailangan natin i-adjust yung fat content niya. So before you move forward with the process and wasting so much time versus let's say yung nalaman mo na lang yung fat content kung kailan tapos na gawin yung product tapos kung may mali hindi mo na mariretoke. So that's one use of NIR. But of course, it's a very expensive instrument, especially for Filipino MSMEs and even the established companies natin sa Pilipinas, iilan lang yung merong ganito. I think mabibilang pa sa isang kamay. Alright. So similar to IR, yung UV technically hindi na siya part ng visible light. Okay, but i-discuss na rin natin. Of course, since this is part of your UV-Vis spectrophotometry, you're probably most familiar with UV as well, and depending on kung anong naabutan niya sa chem, you might have had an actual lab exercise din dito. So, when we say UV, so merong din siyang near, far, and extreme UV based dun sa kung ilang nanometers yung wavelength niya. Okay. And of course, if you have maybe encountered UV in FS127 or FS116, you know that meron din siyang uses as germicidal, okay? Yung tinatawag nating UVC. The late Dr. Al Gabriel actually had a number of published researches on UVC irradiation of mostly fruit juices, no? So for the purposes of food analysis, it's the same use as visible light spectroscopy, and you can also use it for fluorescence determination. Nung undergrad kami, I think we had still an exercise sa Chem 28 or 31 yata regarding fluorescence. And of course, it can also be used similarly to analyze chemical structures. And yun nga, if it's UVC, then it's also useful for disinfection. So to recap, in the past hour or so, we've discussed what we call optical properties, which in this case involve the wavelengths from infrared, visible, and ultraviolet. So for visible light, first we discussed refraction and the use of refractive index for things like total soluble solids and looking at changes in materials. Then we looked at colorimetry, which is defined as the um, trying to quantify colors, no, as the eyes perceive visible colors. And we discussed the different color spaces available, such as the CIE, LEB, and yung hue value, chroma, etc. And we also discussed a bit on sensory evaluation and uh, color evaluation by sight using instruments such as Pantone and your Munsell Book of Colors. So, diniscuss din natin yung near-infrared spectroscopy and looked at how it's useful for determining molecular structures and therefore elucidating what compounds are there and in what quantities. And therefore, meron siyang major use as a rapid method of proximate composition analysis. So we also looked at UV, which is useful both in spectrophotometry, fluorescence, and even microbial inactivation. So obviously, some of these things I did not discuss in detail kasi na-tackle na siya in previous subjects. So we simply focused on colorimetry, refraction, and a bit on NIR, no? But although I think you will encounter some of these again in your food analysis class later. So, I hope you learned a lot in this segment, and please answer the quiz and the activities attached to this segment. And I hope you have a good rest of your week.